In dealing with this radical equation, it looks like we're nicely set up to begin by squaring both sides. That will help get rid of the radical, and then we might have another little surprise within the radical, but then we can take care of it. So let's begin by squaring the left-hand side. And squaring the right-hand side. Well, squaring the square root is just going to give me back the x squared plus 8. And this is a little bit trickier. So let's take a look at a simplified version to help give us a sense of what to do. Well, if I had 2 times x squared, this would just become 2 squared times x squared. So in other words, when we're multiplying, we're just going to distribute the exponent throughout the expression inside the parentheses. So let's do the same thing here. This becomes 2 squared times this guy squared over here. This guy squared is just 2x minus 1. So what do we have? We have x squared plus 8 equals 4. That's the 2 squared times 2x minus 1. Well, it looks like I have a quadratic equation now lurking in the background. But before I solve it, what I'm going to need to do is simplify things a bit. So let me multiply this through and see what we have. Looks like we have x squared plus 8 equals 8x minus 4. To solve quadratic equations, what you'd like to do is move everybody to one side, set it equal to 0, and then either factor it, or use the quadratic equation, or the completing the square method. So let's move everybody to the left. Let's add 4 to both sides. Let's subtract 8x from both sides. See what happens. Well, it looks like I'm left with x squared. Looks like I've got a minus 8x. And it looks like I've got a plus 12. OK, can we factor this? Can we think of 2 numbers that multiply together to give us 12 and add together to give us minus 8? Sure. How about minus 6 and minus 2? So this tells us that x equals 6. X could be equal to 6. Or x could be equal to 2. In other words, I just found out where each of these guys was 0. But what we just did is we just solved this quadratic equation. And we're interested in solving the original radical equation. So what we need to do is we need to plug these guys, 6 and 2, into the original equation to see if they work. Why do we have to see if they work? Because with radical equations, you have to be careful since you can't take the square root of a negative number. And also because radicals, or square roots in this case, can't be negative. So let's see. Plugging a 6 in, we get the square root of 36 plus 8. So I just took 6 squared. And we want to know, is that equal to 2 times the square root of taking the 6 and plugging it in? 12 minus 1, or 11. So again, I took the 6. 6 times 2 is 12. 12 minus 1 is 11. In other words, is the square root of 44, just adding these guys together, equal to 2 times the square root of 11? Well, it doesn't look like they're equal, but this guy's got a little bit of extra fat in it. Because the square root of 44, let me erase this for now. The square root of 44 is the same thing as the square root of 4 times the square root of 11. Why is that? Well, that's true because 44 is 4 times 11. And we have a property of radicals which says that the square root of a product is the product of the square roots. So that's why we're allowed to do that. And then we see that the square root of 4 is 2. So this was a question mark, but now we know it's actually true. And x equals 6 is one of the possible solutions. So let's do the same thing with x equals 2. Let's see what happens. So plugging in x equals 2, we get the square root of 2 squared plus 8. Is that equal to 2 times the square root of 2 times 2 minus 1? Again, just plugging in 2 for x. Well, 2 squared plus 8 is the square root of 12. The right-hand side is 2 times 2 is 4, minus 1 is 2 times the square root of 3. Don't look the same, but again, this guy's got a little bit of fat built into it. There's a perfect square lurking within 12. What is that perfect square? 4. Just as we did earlier, this is the same thing as this. And then this is the same thing as this. And then we know that the square root of 4 is 2. So this is another solution. So it turns out that both of these guys work in this case. To big picture what we did, we wanted to get rid of the radicals. So what we did is we squared them away. Squared both sides, and we were left with, after simplifying, a quadratic. How do you solve quadratics? You set them equal to 0, which is what we did. We found our 2 possible solutions to the original equation. They were solutions to the quadratic, but we had to double check that they were solutions to the original equation because sometimes things go awry since you can't take the square root of negative numbers, and square roots can't be negative. So we had to double check that, and it looked like both of our solutions worked.